3D. What is 3D asking? So we're going to translate math language to English. Line AE is parallel to line GF. And we're trying to decide if that is true or false. So let's check our picture. You are always allowed to use markers, highlighters, anything you need to do to be able to see these lines more clearly, what we are talking about. So, if you studied your vocab like a good student, you read that parallel lines are coplanar lines that do not intersect. And you know that there's a word that's kind of like that, and it's called skew, and that those are really close to being the same, but you might not know exactly how they're the same and different. Let me remind you a few things. So we've got parallel, we've got skew, like this. We've got coplanar, non-coplanar. In the same plane, not in the same plane. Going the same direction, not going the same direction. So let's ask ourselves some questions. Are those two lines going in the same direction? They're both going vertical, right? North, south. What probably confused you is, are those two lines coplanar? Remember, coplanar doesn't mean someone has already drawn the plane for me. No, it means I could put a flat surface through them at the same time. So are those coplanar? Well, look at this. Are planes allowed to shoot through our figures? Yes, they are. They are not allowed to bend, but they are allowed to go diagonally through the figure. So actually those lines were coplanar all along, and so the answer is true. Those are parallel lines. Truth? How do you like that? Truth? Wow. Now, if I had been talking about AE and HG, like right there, one's going this way and one's going this way. Those are skew. Those are not going in the same direction. And guess what? I couldn't put a plane through it. I promise. That almost looks like I could. But they are in totally different orientations, and therefore I could not put a plane through it. It would have to be going up and down for me to really put a plane through it. But it's going this way. So that plane would have to bend for me to grab it. Number 4, part B. Give an example from the picture. Give an example of the point of intersection of two lines. So right now in this picture, I really only see a few lines that are drawn for me, but remember, I'm allowed to draw lines. Let's look at a few that are already drawn. Here's a line that's already drawn. Here's a line. It's kind of already drawn. Remember, planes don't have edges. That is not the edge of that plane. That plane goes on forever. We just can't draw something that goes on forever on the worksheet. But you have to know it goes on forever. Anyways, those are two lines and they're intersecting. What is the name of their point of intersection? The name is X. You name a point by one capital letter. Is that okay? That's just an example. Could you have drawn your own line? That would not bother me. So if you had done this one and this one, then your answer might have been X. Honestly, it could have been any point in the picture. All right, for AA. I'll do AA because it's the second A on the picture. Name 4 non-coplanar points. So I want 4 points, and I want to make sure not all 4 are in the same plane. So there's kind of a strategy to this. I'm going to pick 3 points in the same plane. V, S, U. V, S, and U have something in common. They are all in the pink plane. Now I'm going to purposely pick a point that is not in the same plane as them. I'm going to pick a point in the yellow plane that's not in the pink plane. I just named 4 points, and I could never put one plane through all 4 of those points. As long as V, S, and U are not collinear, but let's pretend they're not. So anyways, I picked 3 are in the pink plane, 1 is in the yellow. They are non-coplanar. We are going to take some notes today, so please get out a sheet of paper, and we are going to go over notation again, because it's that important to me. I will never count off for spelling. On the vocab quiz, if you spell collinear wrong, you go for it. I will give you credit for that. But on the vocab quiz, if you do your notation wrong, I will take off points. Because notation is important in math, whereas spelling, like the fact that collinear has 2 L's, I'm not super worried about that. All right, let's see if we can remember how to notate all of these things that we learned about. Number 1 is saying point. Look at our picture, and let's name a point. We did this on the homework plenty of times. A point is where 2 lines meet. We're going to learn more about that today. But I can pick a point from my picture. I name a point with 1 capital letter, and I'm done. I don't even need to put the word point in front of it, because when I use a single capital letter, Miss Tanton knows I mean a point, because that's notation. Let's name a line from the picture. I'm going to go crazy. I'm going to name line JM. JM is not drawn, but yes, it's still a line from the picture. Now, if I put that on my vocab quiz tomorrow, I'm going to get points taken off. Because how I wrote it right now, that says the distance from J to M. I didn't want to say that, so I wrote the wrong thing down. I wanted to say the object, line JM. Okay, now my notation is correct. Now I got all my points. Let's name a plane from the picture. Now, there's no italicized letters like that in the corner, so I can't use that choice for naming a plane. I have to use my other choice that my vocab page says. It says to use 3 capital letters. I'm going to name the top of the prism. X, Y, W. Did I put commas in between those letters? No, I'm not listing points. I am naming a single plane. So that should be one thing, one notation. X, Y, W, J, M, K, however you want. 3 capital letters. You can actually label it with 3 or more capital letters, but 3 is enough. Segment. I'm going to take a segment. I'm going to make sure I use the right notation. Segment should never have arrows. Segments have a beginning and an end, so they should not have arrows. Array. I will pick any 2 letters I want. Let's see. How about Ray, K, J, because it rhymes. Remember, array needs to have 1 arrow. And in our class, we always point the arrows to the right because we read from left to right. So that's going to be the best way to draw our array notation. Y'all remember the symbol for congruent? Picture it in your head. Okay, I can see it. Yep. Equal sign with a squiggly on top means that 2 segments are congruent, the same length. Parallel, close your eyes and picture the symbol for parallel. Okay, got it. And perpendicular. This one actually is not on your vocab sheet because we're going to go over it more in a different unit, but it's still a really good symbol to know. Upside down capital T. Good? Now, if I wanted to go a little bit further, I could have said XP is parallel to ZK, right? That's a whole sentence. Line XP is parallel to line ZK. I could have said, let's see, segment JK, LOL. I'm just kidding. Segment JK is perpendicular to segment YJ. Those are perpendicular right there. So I could have written a whole sentence if I wanted to. Today we're going to learn about 4 basic postulates. If you walk away from class and this is what you remember, then I have done my job. 4 postulates that are literally the building blocks for all of geometry. So in your notes, you can organize it however you want, but we're going to learn 4 important postulates. And the great news is a lot of them are common sense. You're like, duh, Ms. Stanton, like, why did you have to even write that down? All right, so we have a coordinate plane. We plotted a point, and then I asked you to draw a line through your point. All right. Did you draw my line? Is that the one you drew? Oh, I assume that not everyone drew the exact line that I drew, right? Oh, I have to call it M. So if I give you, we all have the same point, correct? We were all working with the same point, yet we all drew different lines. So what do you think that we could say there exists how many lines through one single point? I give you a single point, how many lines could we draw potentially through it? Yeah. We could go on, pretend I'm going through that point, pretend I'm getting this right. We could sit here forever and keep drawing new unique lines through point A. We all have the same point, but there are infinite number of unique lines to that point. So does one point define a line? No, right? One point is not enough. So this is infinite. An infinite number of lines through a single point. Okay, now let's try something else. We're going to see how many things you remember. Go ahead and plot the point 3, 5. Once you've plotted point 3, 5, now I want you to reflect it over the y-axis. Reflect means flip, if you remember from previous math classes. So take that and flip it over the y-axis, and it says call it B prime. Then it says draw a line through points B and B prime. Ooh, Miss Stanton's line was pretty straight. Okay, compare your line to my line. Compare your line to the people around you. What do you notice about your line, my line, and their line? So on the last slide, we were like, oh, we could draw an infinite number of lines to that point. But what if we add just one more point? What if there's 2 points? How many lines exist through those 2 points? How many lines? Just one. Is my line longer than your line? Is my line shorter than your line? Or are they literally all the same exact line? Remember, lines are infinite, so no one line can be shorter or longer than someone else's. So we all literally drew the exact same line. So, that is postulate number 1. Star it, underline it, bold it, box it. Through any 2 points, there is exactly 1 line. That is a basic building block of geometry. Through any 2 points, there's exactly 1 line. Sorry, it takes 2 points to create a unique line. It takes 2 points. That's easy to remember. How do you name a line? Oh, you name a line using 2 points. So once it has a name, it's unique. So that's kind of easy to remember. It takes 2 points to make a unique line. All right, sketch a new coordinate plane real quick. Draw any 2 lines you want. Draw me 2 lines on your coordinate plane. Go. Okay, you drew any 2 lines you wanted to on your coordinate plane. Did your lines, yes or no, did your lines intersect? What about my lines up here? Do my lines intersect? Do my lines intersect? Remember, those have arrows on them. Your lines better have had arrows on them. Those lines go on forever. So even though they're not intersecting yet visually to us, they absolutely are intersecting. Now, when and if your lines intersect, did anyone's not intersect at all? If someone's didn't intersect on their paper, what are their lines called? If someone's did not intersect, what were their lines called? Good, parallel. So not everyone had to draw lines that intersected. Yours could have been parallel. But if yours were not parallel, then that means your lines intersected. Now, what do you get when 2 lines intersect? Do they intersect in a point, in a line, in a plane, in a ray, in a segment? What do you get when 2 lines intersect? Point, line, plane, segment, ray? You're right. When 2 lines intersect, they intersect in exactly 1 point. And you could call it something. There you go. Do all lines intersect? I think we kind of already went over this. Draw 2 lines that don't intersect. We talked about it. They would have to be parallel. Okay, now try this one. I want you to draw 2 lines, and I want you to make them intersect more than once. I sure hope that your conclusion was that it is impossible. Lines cannot intersect more than once. And that's a really great question that you're asking. If I drew this line, and then I drew this line, is my green line and my blue line, are those intersecting infinitely? The answer is no. They are the same line. So it's not two lines intersecting infinitely. It's actually the same line. So, can two lines intersect more than once? The answer was nada, no, sorry, denied. Okay, so we have a postulate to write. We have a postulate number 2. If two lines intersect, because remember they don't have to, if two lines intersect, then they intersect in exactly what I'm saying? 1 point. If two lines intersect, then they intersect in exactly 1 point. Postulate number 2, basic truth of geometry. Let me say a little caveat here. We study what's called Euclidean geometry. I introduced you to Euclid the other day. We study his geometry. This is not the only geometry out there. There is spherical geometry. There's something called taxicab geometry. In spherical geometry, you might have different truths than in Euclidean geometry. But don't worry, right now, for here, we're studying Euclidean geometry. In spherical geometry, lines aren't even straight. Whoa, mind blown. Okay, what makes points collinear? Plot 2 points on your graph that are not collinear. Stop giving me impossible tasks, right? You can't. You cannot plot 2 points on your graph that are non-collinear. You just can't. What about a point right here? What about this point and a point hanging out on Jupiter? Could I connect those with a straight path? Yes, I could. Any, the point of this is, any 2 points in the universe are collinear. Any 2 points in the universe are collinear. This is not a postulate. This is not a postulate. It's just a discovery. Okay? I'm going to call this A and B. Any 2 points are collinear. I'm going to go ahead and tell you that one's true. Read B. What do you think about that one? Any 3 points are collinear. Can we do it with 3? Are we allowed to just change that number? What do you think? False. Very good. Now, when something is false in math, we like to prove it wrong. We don't like to just say it's false. We like to show how it's false. So we are going to draw or write what's called a counterexample. Can you draw a counterexample in your notes? There's 3 points, and they are not collinear. That's called a counterexample. Good job, people drawing on their cameras. Wow, I love it. All right, postulate number 3. If 2 planes intersect, because, by the way, they do not have to intersect. So if 2 planes intersect, what do they intersect in? What do you get when 2 planes intersect? A point, a line, a plane, a ray, a segment. What do you get when 2 planes intersect? Good. Good. When 2 planes intersect, they form a line. A line, those are the points they have in common. They have all of those points in common. And if you connect them, what points they have in common? Share, 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 share. I'm sharing all these points. I'm sharing, sharing, sharing. And then you connect those points, and you get a line. Okay? So that is postulate number 3. If 2 planes intersect, because they don't have to. They don't have to intersect. But if they intersect in exactly 1 line. I'm not really going to give you time to draw the picture, but I do want you to write the postulate. Write the sentence only. How many points does it take to make a unique plane? Okay, I have a skewer in my hand, something you can make shish kebabs out of, and I want to know what you think the top of my skewer represents. point, right? Okay, so I'm going to use this. I'm going to try 1. How many points does it take? Let's see if it takes 1. If I have 1 point, do I have a unique plane? How many planes could I come up with that go through this point? An infinite number of planes. 1 point is not enough to create a unique plane. Sorry. Okay, let's try 2. I have 2 points. Ooh, I've got a plane. But wait a minute. Can I tilt this without losing my points? Do you think I can still tilt this plane? How many planes go through 2 points? Also an infinite amount. All right, let's keep going. 3 points. I'm going to put my plane on them. Oh, maybe. It's hard to do this with only 2 hands. Okay, 3 points in 1 plane. Now I'm going to start rotating my plane like I did last time. Oh no, I lost a point. Oh, I lost a different point this time. I lost my back point. Every time I try to lift my plane to rotate it, I lose a point. So how many points does it take to create a unique plane? Good. It takes 3 points to lock us in. I am locked into that plane now. I can't rotate it. It's stuck. Now, this is something really important. Now, what if I had taken those 3 points I was discussing with you, and what if I put them in a row? What if I did that? That's 3 points, guys. That's 3. What if I put my plane on it? Can I rotate my plane and still touch all 3 of them? Sure can. So we need to say something about that. It takes 3 points to make a plane, but what kind of 3 points? What has to be true about those 3 points? To create a unique plane, those 3 points need to be non-good. That's postulate number 4. That is the last postulate of the day. Through any 3 non-collinear points, there's exactly 1 plane. Write it down. So this is why a tripod is called a tripod. Why isn't it called a bipod? Why doesn't it just have 2 legs? Because it would fall over. Why isn't it called a quadpod? How come a tripod doesn't have 4 legs? Have you ever sat in a desk with 4 legs that wobbled? It's pretty annoying, isn't it? The reason a desk wobbles with 4 legs is literally because of geometry. And that's why geometry is so beautiful. So if the desk has 4 legs, 3 of those legs might be coplanar, and then the 4th one might not be in the same plane as those 3 other ones. That's what makes your desk wobble. So actually, the most stable you can be is an object with 3 legs, because all 3 have to be coplanar. Any 3 points are coplanar. Any of them in the universe. A point on Pluto, a point on Jupiter, and a point on the Earth. Those are coplanar. I don't care where they are. Any 3 points are coplanar. So that's why tripods are so stable and why they're called tripods. I'm going to summarize these postulates because it's so important. After we've just talked for 1 hour, what do you walk away with? Here's our postulate. Through any 2 points, there is exactly 1 line. If 2 lines intersect, they intersect in exactly 1 point. If 2 planes intersect, they intersect in exactly 1 line. And through any 3 non-collinear points, there is exactly 1 plane. Yay! Last thing I want to leave you with. Is it possible for 2 planes to be skew? We talked about, I showed you, I said, planes don't have to intersect. It says if they intersect. So we know that planes can be parallel. We know they don't have to intersect. But could planes be skew? If I try to do with my arm, parallel, skew, skew. If I try to do that with my planes, parallel, skew. Well, uh-oh. This guy, because I know planes go on forever, this guy's going to hit this one eventually. Because they go on in all directions, not like a line that just goes on in two directions. So, just leaving you with this, it is impossible. It is not possible for two planes to be skew. Lines can be skew, but planes cannot.